Classification of wave depending on medium requirement. If medium is required or not, from that point of view, it is divided in two categories: mechanical wave or non-mechanical wave. Mechanical wave, also known as the elastic wave, and non-mechanical wave, also known as the electromagnetic waves. So mechanical waves are the waves that need a medium. Medium means solid, liquid or gas for its propagation. And non-mechanical waves, they do not require any material medium for their propagation. Sound waves, wave produced in string, wave produced in spring, and water waves are some examples of the mechanical waves. The electromagnetic wave, that is the radio wave, infrared wave, visible light, is the example of non-mechanical wave. Mechanical wave cannot travel through vacuum. Non-mechanical wave can travel through vacuum. Mechanical wave can be transverse or longitudinal. We will discuss just after some time. And non-mechanical wave are only transverse in nature. Now we will divide the wave in two categories depending upon the direction of vibration of particles. It is divided in two categories. One is a transverse wave, another is a longitudinal wave. Transverse wave. If we say this is the direction of the propagation of the energy, and if medium particles are vibrating like this, it means both are perpendicular to each other. This is the vibration of the particle of the medium, and this is the direction of the wave propagation. Then we will say it is known as the transverse wave. So transverse waves are waves in which oscillation of medium particle are perpendicular to the direction of propagation of wave or energy flow. This is the direction of propagation of wave, direction of energy flow or wave flow, and this is the direction of vibration of particle of the medium. Now if you look at any particle, suppose you are observing this red particle where I have drawn this vertical line. If you look at this particle, this red particle is just moving up and down vertically. It cannot dislocate from its respective position towards right side or towards left side. And this is the condition of the wave motion. Particle cannot dislocate from a respective position. So I hope it is visible to all of you with this animation. This is the graph of the transverse wave. This is the maximum upward displacement. It is known as the crest. This is known as the maximum downward displacement. It is known as a trough. So we can say a transverse wave is composed of the crest and trough. If we have to measure the wavelength of the transverse wave, we can measure it by measuring the distance between two consecutive crests. This is known as the one wavelength. And wavelength is written as a symbol lambda. Distance between two consecutive trough, it is also known as the one wavelength lambda. Longitudinal wave. If I say this is the direction of wave propagation or energy flow, and if medium particle is also vibrating in the same direction, this is the direction of propagation of wave. This is the vibration of medium particle. Both are parallel. It is known as the longitudinal wave. So longitudinal waves are the waves in which oscillation of the medium particle are parallel to energy flow direction or direction of propagation of wave. You can observe this red vertical line. The red vertical line is moving to and fro, and wave or energy is also flowing in the same direction. This is known as the longitudinal wave. In this animation, it is visible to all of you. There are some points where you can say pressure or density is maximum. It is known as the compression. I hope it is visible to all of you. This compression is moving. And there are some points in the space where pressure or density is minimum. That point is known as the rarefaction. I hope it is visible to all of you. This is rarefaction. So compression are the point in the space where pressure or density is maximum. Rarefaction is the point in the space where pressure or density is minimum. And distance between two consecutive compression or two consecutive rarefaction in the longitudinal wave is known as the wavelength. Now we will discuss some examples of the longitudinal and transverse wave. Transverse wave example, wave on the string. If we take a string attached to a wall and just give a jerk to the one end, then string will oscillate as shown in the animation like this. And we can say The direction of the vibration of the particle of the medium is like this. It means both are perpendicular to each other. It is known as a transverse wave. Here we have shown you this particle, which will show you the particle of the medium is vibrating perpendicular to the direction of flow of energy. Waves in the slinky. Slinky can produce both the wave transverse as the longitudinal wave. In the transverse wave, direction of the vibration, direction of the wave, this is the direction of the wave, and this is the direction of the vibration of the particle of medium. Both are perpendicular to each other. In longitudinal wave, you can observe here, direction of the wave propagation and direction of the vibration of the particle both are parallel to each other. So slinky can produce both the wave, transverse as well as longitudinal. Sound wave is the longitudinal wave. As we beat the drum, particles of the medium vibrate and vibration reaches to the ear in the form of the compression rarefaction. Somewhere the particles of the air come closer, that is the compression, and somewhere the particles of the air goes far away, that is known as the rarefaction. So sound wave is an example of the longitudinal wave. Now we will discuss the difference between the longitudinal and transverse wave. In the transverse wave, particles of the medium vibrate perpendicular to the direction of the wave propagation, like this. Example of the string. Longitudinal wave, particles of the medium vibrate in the direction of the wave propagation. Sound wave is the example of it. In the transverse wave, the propagation of the wave is possible in solid only or surface of the liquid, but not inside the liquid and gas. The propagation of the wave, that is the longitudinal wave, is possible in all types. It may be solid, it may be liquid, it may be gas. All of you can know sound can travel through the solid, can liquid, and can gas also. Transverse wave can propagate as crest and trough, and longitudinal wave can propagate as compression and rarefaction. Example of the transverse wave, that is electromagnetic waves. These are the light waves, radio waves, microwaves, ultraviolet rays. Example of the longitudinal wave is a sound wave I have discussed. One more example I am taking here. There are the waves at the time of the earthquake.